Now we will see how the part number 5, that is bolt, okay, M10 bolt can be modeled. Okay, so let's search for the part number 5, that is M10 bolt. So M10 bolt is given here. Okay, so they have given only one view for that M10 bolt. We can take this as the front view, and as it can be seen here, bolt is nothing but it will have headed part and threaded part. Okay, so this is the head, and for this head they have given it as a square symbol here. The meaning is that this head will have square shape of in which each side will have 18 mm. Okay, and in this rod part of the bolt, okay, so for 26 mm length there is a thread, and overall length of this rod, cylindrical portion of the rod, cylindrical portion of the bolt is 75 mm. So, and this thread is of M10 type, that is metric 10 thread is used here, that is nominal diameter of the thread is 10 mm. Okay, so now let's see how this model or how this square headed bolt can be modeled now. So for that I will go to the SolidWorks, I will go and click on new part. Okay, select, give OK now. Wait for the software to respond. Okay, so now what I do is first I will go for creating this head. Okay, so square head will be created first. So for that I'm going to select the top plane first, and I will create a sketch on the top plane. I'm going to select in this case center rectangle. From the center or from the origin of the working window, I'm going to draw one square like this or rectangle like this. Then for one of the side will be given as a horizontal side will be given as 18 mm, and since it is a square head, so other side should also be 18 mm. And once we add dimensions of 18 into 18 for this rectangle, so you can see here the sketch is fully defined now. We can come out of the sketch plane and we can keep this in isometric view, and we can verify where it is created. So this is created in the top plane now. So now I will go for adding the material within this profile by using this extrude option. So go to features, there you select extrude option. Okay, so there we need to add the material for, for a height of how much, 6.5 mm. So therefore what I do now is I go for adding this for 6.5 mm. And when I do this, let me check it here. Where is my front plane? My front plane is here. Okay, this is my right plane, this is my top plane. Okay, so now what I do is I will go for adding this cylindrical portion of the bolt. Okay, that can be added by selecting this top face here. So select this top face of the square head. Okay, and then go for selecting sketch command. Okay, means we are trying to make sketch on this top face of the square head now. So keep it in top view, and then select circle command. Draw one circle from the origin. Add a dimension for this circle. So since it is a M10 bolt, the diameter of this uh, rod should be how much? 10 mm. So it is given here. So give this as 10, and you can see sketch is fully defined. Exit from the sketch mode, go for isometric view, and then select features command manager tab. There in the tab, go and choose extruded boss option. Now I can add the material within the circle in the upward direction. So here the overall length for which the material should be added is 75 mm. So I'm going to give this as 75 mm now. Okay, so this is how it looks. Okay, this is the draft this is the draft model of the which one, square headed bolt. Okay, so still we need to add a cosmetic thread here, we need to make a chamfer here. Okay, and this square head should be chamfered. Okay, so if I try to keep this in front view, it is going to appear like this. Okay, so now what we need to do is we have to add this thread here. So thread should be there for 26 mm length, and then this should be chamfered. So therefore what I do is I go for selecting, I will go to insert, okay, and then I will go to the annotations. There I'm going to use cosmetic thread. Okay, so then first it will ask for a circular edge from which the thread has to be placed. So I'm going to select this top circular edge here. Okay, and then it will ask for the diameter. So you can just go with the default value, or here you can go for selecting the ISO thread. Okay, or you can also select metric thread. So here metric thread of how much, uh, 10 mm should be selected, but they have not mentioned anything about the pitch. You just go with M10 into 1. That is, pitch value will be uh, 1 mm. Okay, so then it is not up to the next. Thread should be there only for certain length of the rod. Okay, so the overall length of the rod is 75 mm. Only for certain portion now thread should be placed. So thread should be there for a length of 26. So therefore, from the top circular edge, okay, so it should be given for how much? 26 mm. So once it is added, click on OK. But right now we are not able to visualize the thread that we have placed on the cylindrical rod. Okay, so if you try to expand this extrude to here, okay, already cosmetic thread has been placed, but it is not visible now. So in order to make it visible, what we do is we will click on this SolidWorks option here. So click on this, and then go to the document properties, go to okay, detailing here, then go and turn on the shaded cosmetic thread. Okay, then click OK. So once you turn on that shaded cosmetic thread, then this the graphics of the thread will be visible over the rod of the bolt. Okay, so then what we need to do is so now actually uh, this is the front view. So in this front view, if you look at here, if you try to look at here, here there should be a chamfer unless otherwise mentioned. It is given here. Okay, unless otherwise mentioned, a chamfer of 1 mm length and 45 degrees should be provided. Okay, so therefore what we do is we go for selecting. So we go to the features tab here, and then under that we go to the fillet. Under fillet, okay, we choose chamfer command. So once we select the chamfer commands, okay, select this circular edge. Here the chamfer length should be 1 mm and angle should be 45 degree. Click OK. So now you can see chamfering has been done. So now if you try to keep it in front view, it is going to appear like this. So you can see the chamfer which is made here, and this is how it looks in the top view. And this partial circle appearing here represents the presence of thread over the rod surface. Okay, and almost this modeling of the square-headed bolt is complete now. Okay, but only thing is there is a arc appearing here. Okay, if you try to observe this head of the square bolt, okay, so here there is a arc. This arc actually corresponds to the chamfering. Okay, which is made on the uh, which is made on this particular face here. So on this particular face, chamfering has to be done for 30 degree. Okay, so then we are going to get the which one that arc means around the axis of the bolt we have to cut the material for 30 degree. Okay, like this. So around this axis for 30-degree angle the material should be cut. So now I will just show you. See in the exam, if you are not able to do the chamfering and all, so just ignore it. Okay, because you may lose 1 or 2 marks for that. But okay, so it will take some time for doing that chamfering on the head of the square bolt. Okay, so okay, is that clear? So you can treat this itself as the final bolt, and you can go for assembly. Okay, otherwise if you want to really get that chamfer, then you just follow what I'm going to explain now. So first what I do is I'm going to keep the model in isometric view. Then I will check where is my front plane. So right now my front plane is not passing through. Okay, so uh, uh, any of the corners of the square head. So this is the square head, but front plane is not passing through the corners of the square head. And also if I try to check the right plane, okay, so where is my right plane? So if I try to select, this is front plane. So let me keep it in isometric view, and let me try to select my right plane. So this is my right plane. Okay, so this right plane is also not passing through any of the corners of the square head. Okay, so therefore what I do is I need one plane. See, in order to do the chamfering, okay, we require a plane which is passing through opposite corners of the square head. Means there should be a plane which is going to pass through this point and this point. Okay, so so we need to go for creating a new plane now. since none of the default planes are passing through the which one corners of the square head, okay, opposite corners of the square head, we should go for creating a new plane. Where we can create the new plane, go to the features, go to the reference geometry, go and select the plane command. Okay, then once you select a plane command on the left side, okay, on the left side under properties manager or under the plane properties, it will ask for selecting the first reference plane. So my first reference plane or the first, see, you can, if you look at here, okay, this is plane, you can see there is a point here, there is a edge highlighted, there is a face highlighted. My first reference can be a point, it can be a plane, or it can be a edge. So what I do here is I will select this particular point as the first reference. See, you can see vertex 1 is selected. Second reference point I'm going to choose select as this. Okay, and then third reference point I'm going to choose as this. So now you can see that there is a new plane appearing in blue color here. Okay, transparent color, transparent blue color. Okay, so this particular plane, that is new plane which is appearing now, is passing through the opposite corners of the square head. So once we get once this plane appears, click on OK now. So therefore there is a new plane 1 which is passing through the opposite corners. Now on this new plane 1 I am going to create a sketch. Okay, so that sketch has to be made. So what sketch has to be made I will explain soon. Okay, but before that what I do now is I am going to select this bottom face of the square head. Okay, and by selecting that I will go for creating a sketch now, and I am going to keep it in top view. And what I do now is I will select circle command. I will try to draw a circle which is going to touch, which is going to become tangent to all the four sides. In order to make it tangent to all the four sides of the square head, so I will select the circle first, and then I will select one of the edge of the square head, and I will make it as a tangent here. So once it is done, okay, so this circle actually represents that, okay, outside this circle the material has to be removed for 30-degree angle. Okay, so means if you try to tilt this model now, so what I am trying to tell here is, okay, so this is the bottom face. So this is the circle that we have created now. Okay, so this circle is created on this face. Now, okay, around this circle, okay, or outside this circle, the material should be removed for 30-degree angle. Then we are going to get the chamfer arc. Okay, so that's why this circle has been created. This you can use it. This is only for our construction purpose. Okay, once this circle is constructed, this is called as a chamfer circle. Then exit from the sketch mode. Once you exit, now I am going to select the plane, okay, new plane that I have created in the previous step. So this is the new plane which is passing through the opposite corners in the square head. Okay, so I will select that particular plane and I will go for sketch mode, and I am going to keep this particular, I am going to right click on the plane one, and I am going to click on this icon, that is flip normal, or this one. Okay, so I'm going to click on this icon, okay, so that it will be that selected plane one becomes parallel to the screen. So like this. So then what I do is I'm going to construct one uh, triangle now. So right angle triangle will be constructed from this particular head, here or here. So wherever you want you can construct it. Now I will choose from here. So first I will draw one horizontal line, then one inclined line, okay, and another vertical line. So this is what I am. So this triangle actually represents like. So now you can see there is a circle appearing here, and this is the triangle that I have constructed on the plane which is passing through the opposite corners. Now for this triangle shape, okay, the material should be cut around that created circle. Okay, means like this. So for this triangle shape, the material should be removed around the created circle. Okay, so that is what you need to remember now. So but what should be the dimensions of this triangle, that we have to give now. Okay, so go to the sketch now. Again go for smart dimension. Okay, and I'm going to give the angle between this line and this line. This line should be 30-degree angle, unless otherwise mentioned chamfer angle will be 30-degree. Add it. Then I will select this particular point here, okay, this point of the triangle, and I will select this circle. Okay, so the circle around which the material should be cut will be selected, and this particular point will be selected on the triangle, and I am going to pierce them, means I am going to connect them. So once it is connected, you can see sketch is fully defined now. Okay, so now we can go for cutting the material around this circle. But in order to cut the material by revolve option, we need an axis. So that axis is not created here. So in order to create that axis now, I'm going to keep this in front view now. Okay, then I'm going to select center line of command, and from the origin I'm going to draw one center line like this. Okay, so now also the sketch is fully defined. So if you want, you can try to keep it in isometric view now, and you can check. So there is a center line created. There is a circle here. This particular circle is connected to this triangle, and the bottom end of the triangle, the bottom left end of the triangle is connected to the circle now, and the angle between this inclined line and this horizontal line is 30 degree. That is the chamfer angle. Now the sketch is ready for which one? Creating the chamfer. Okay, so what I do now, if you want, you can go for right click on the plane one, you can go for hiding it. Okay, so once it is done, so now I will go for exiting. I will exit from the sketch now. Then I will go for features. I will go for revolved cut now. Okay, so select revolved cut. Okay, since axis is created already, so the axis has been selected automatically here, and the profile is also created. You can see now, okay, how the software is trying to cut the material. So or let me try to reduce the, you can check it here. So this is how the material is cutting. So I am just decreasing the angle for which the material should be cut. You can see now for the triangle shape. Okay, we are trying to cut the material, and that triangle is having an angle of 30 degree. It's a right angle triangle with 30 degree. So you can see now. So this is how the material will be removed. Okay, around that created circle, and about that bolt axis. So like this. Okay, so it will go like this, and if you want, you can also go for increasing the angle of cut. So here the angle of cut should be 360 degree. So this is what I am trying to show you. So without this triangle, we cannot go for creating the which one. We cannot go for cutting the material, or we cannot go for providing the chamfer. Okay, so therefore I will go for giving this angle as 360 degree. Okay, so once it is done, click OK. So then you are going to get the chamfer as something like this. Now this particular circle can be made hidden. So I am going to select this sketch 3, which is the circle which is tangent to all the four sides of the square head. I am going to hide this particular circle now. Okay, so once it is made hidden, okay, so the square head is going to look like this. So like this. So this is the chamfer made. Okay, so chamfer made around the square head like that. Okay, so once it is done, I think this completes the modeling of the which one square headed bolt. Now you can keep this in the front view. Okay, you can see, if you want, you can turn on the hidden edges. This is how it looks. Okay, now you can see the chamfer arc here. So this is the chamfer arc. Okay, so this is exactly same as the which one? This is exactly same as the front view, which is front view of the square headed bolt given here. So this exactly matches with this the figure given here. That is front view given here. So therefore modeling of the part number 5 is completed now. So let me keep it in isometric view, and let me bring back the solid form. Then I'm going to save this as part number 5 in the Plummer Block folder. Okay, so part number 5, and this is which one? Square headed bolt. Square headed bolt. Save it. Okay, so once it is done, you can close this file now. So now we will move on to modeling of part number 6, that is nut. Okay, so this particular nut will be called as the load nut. So let me show you how this particular nut can be modeled. So where is that nut? Nut number 6 is given here. So now only difference between no, part number 6 and part number 7, that is load nut and lock nut is, okay, so it is there only difference is with the thickness of the nut. So in the case of load nut, thickness is 8 mm. In the case of lock nut, the thickness is 5 mm. Other than that, okay, okay, both the nuts are having same thread of M10. Okay, so therefore both these part number 6 and 7 are geometrically similar except the thickness value. Therefore, if we create part number 6 with help of part number 6 itself, we can go for getting the part number 7. So let me quickly demonstrate how we can make the part number 6 now. So let me close this working window, and let me take up the new part file. Okay, so then for this part number 6, that is load nut, they have given the front view and they have given the right side view. So therefore what I do now is I am going to create a hexagon. So this hexagon will be created on the right plane first, and it will be extruded for the length of 8 mm. So let me go for selecting the right plane. Okay, so this is the right plane. Okay, so right plane has been selected. Then go for sketching it on the right plane. Okay, and then go for selecting. There is an option called as polygon here. So in in sketch command, okay, under sketch command manager, you can see there is an option called as polygon. Select that, and from the origin of the working layout, go for constructing the which one? Go for constructing one hexagon like this. Okay, so you can change the number of sides. See, we are constructing polygon. Okay, if you enter here 5, you will get 5 sides. If you enter 4, you will get 4 sides. If you enter 3, you will get 3 sides. Okay, if you enter 7, you will get like this. So like that, so how many numbers you want, you can add it here. Okay, so but here we need, it is a hexagon nut. Therefore I'm going to give the number of sides in this particular polygon as 6 now. Then click OK. So then what we need to do is the sketch is appearing in blue color, means it is not constrained. Okay, means we can increase the size of the hexagon here, or we can rotate the hexagon. So this should be prevented. How to prevent this? So let's go for checking the dimensions of this nut now. Okay, so it is M10 nut. The meaning is that inner diameter is 10 mm, while the outer diameter they have not given. But from the proportions of bolt and nut, okay, we can say that okay, the distance between the two corners here should be equal to 2 times the inner diameter. If the inner diameter is 10, then the distance across the corners should be equal to 2 times 10, that is 20 mm. So therefore what I do now is I'm going to define the distance between these 2 points as how much? 20 mm. So this will be done. Okay, and also what I do is I will select one of the top point, because once I define 20, we cannot change the size of the hexagon, but the hexagon can be rotated like this. So in order to prevent the rotation, what I do is I will select one of the point here. Okay, so this particular point will be selected on the sketch, and this origin will be selected, and I am going to establish vertical relationship now. Okay, so once it is done, since nut is nothing but it is a hollow component with inner surface having thread. Okay, so what I do is I will also go for creating one more circle now. Okay, from the origin. So create one more circle, choosing the origin as the center. Then give the diameter of the circle as 10 mm here. Okay, so therefore this should be 10 now. So you need to remember, okay, M10 thread is given for the nut, means the inner diameter of the nut is 10 mm. Then the distance between the which one? The corners of the hexagon should be what? 20 mm. That is 2 times 10. So this proportion you should know. Once we construct this circle and this hexagon, then we can go for adding the material between this circle and the hexagon using extrude option. So you can see the sketch is fully defined now. I will exit from the sketch now, and I will keep this sketch in the isometric view. You can see now this is created on the which plane? The right plane. So then I will go for features, then I will go for which one? Extrude, selecting the extrude option. Then here I am going to add the material on either side of the sketch. So mid plane option will be used. Now for this part number 6, that is load nut, the thickness of the nut is how much here? 8 mm. So therefore the extrusion depth should be 8 mm. So then click on OK. So so this is how it looks. So this is looks like hexagon nut. Okay, but what we need to do, we need to give for this inner surface we have to add the cosmetic thread. So go to insert. Okay, go to annotations, go to cosmetic thread. Okay, so then try to select this circular edge here. Okay, from which the thread should be placed. Then I'm going to use metric M12. So the software is by default taking M12 thread. So let's go with the default values. Then blend, instead of blend, go for through. Okay, then click on OK here. You can see there is one more circle appearing now, which is the indication of there is a thread now. And now but that inner surface is not showing any thread appearance. So what I do, I will go to the SolidWorks option, and here I will go for selecting document properties. Under document properties, go to detailing. There you go and turn on the shaded cosmetic threads. So once it is done, now we can visualize the which one here? Thread on the inner surface. Okay, so this almost completes the modeling of the nut. But again, if you try to keep it in front view now, this is how it appears. Okay, and if you try to turn on the hidden edges, okay, this is how it looks. Okay, and if you try to compare this front view here with this front view, only difference now is on the right face and on the left face, of the nut. Okay, so as you can see here, so chamfering has been made for 30-degree angle. Okay, so therefore the top face of the nut and the bottom face of the nut has to be chamfered. Okay, or the right face of the nut and the left face of the nut should be chamfered with an angle of 30-degree. Now, similar to how I demonstrated the chamfering of square-headed bolt. Okay, in the same way we can go for chamfering the which one, hexagonal nut. Okay, so let me show that. Okay, let me go for demonstrating now how the chamfer can be added. See, if you feel that this much is sufficient, okay, for the assembling, you can treat this itself as the final nut. Okay, and you can go for assembling. Okay, otherwise, if you still want to accurately get the nut, go for adding the chamfer. So now I will show how to add the chamfer, 30-degree chamfer. Okay, 30-degree chamfer for the right face and left face of the nut. So that can be added by selecting first. So let me keep this model in the isometric view. Let me select the front plane. Now, okay, so you can see here the front plane is passing through this corner and the opposite corner. So therefore the front plane can be used, okay, for creating the required sketch. Okay, is that clear? But before to that, what I do now is I'm going to select this particular face, okay, of the nut. That is right face of the nut will be selected, and I'm going to create one circle on that particular face. Okay, so go for sketch and keep it in right view, and go for selecting a circle command. From the origin, draw a circle. Okay, and make this circle, okay, tangent to one of the side here, one of the side of the hexagon. So select the circle, created circle, and the one of the edge here, hexagon edge. Then click on tangent here on the left side. Once it is done, you can see this is the created circle. So this is the circle that we have created, okay, which is touching all the 6 sides of the hexagon now. Okay, now what we have to do? We need to cut the material, okay, outside this circle. We have to cut the material outside the circle. For what angle? For 30-degree angle. Okay, and around the axis. So therefore, in order to do that, we need the cutting profile. So that cutting profile will be constructed now in the plane, in the front plane. So I'm going to select the front plane now. I'm going to select the front plane. Okay, so by selecting the front plane, I'm going to keep the nut in the front view. Then what I do is I will go for selecting line command. Okay, here somewhere here now I'm going to construct one. Let me exit from the sketch. Something is not working. Let me correct it. So I will select the front plane now. Select the front plane, then go for sketching it in the front plane. Okay, keep it in front view. Then what I do is I will select line command. Now I will try to create a triangle here. Okay, right angle triangle will be created like this. Okay, so now just let me turn like this. Okay, now as you can see, this is the circle that I created in the uh, previous step. Okay, so around this circle, means outside this circle I have to cut the material. Okay, and for what profile I have to cut the material? For this triangle profile. Okay, so now this particular point on the triangle should touch this circle. Okay, so this created circle should make contact with the which one, this particular point on the triangle that we have created, because within this triangle we have to cut the material. So for that, what I do now is I will select this particular point here, and then holding the control key, select the circle and give the Pierce relationship, so that okay, that particular point coincides with the circle that we have created. Then what we do now is if I try to keep again this in front view now. Okay, so now we have to give the chamfer angle. So select smart dimension. The angle between this inclined line and this horizontal line should be 30 degrees. This is the chamfer angle. So now you can see sketch is fully defined, and we need to cut the material within this triangle. Okay, and we have to cut the material around this circle. For that, we need an axis. In order to get the axis, I will keep it in front view now. I am going to select center line command, and from the origin I'm going to draw one center line like this. Okay, now you can see the sketch is fully defined. Exit from the sketch mode. Okay, so this is what we have created now. There is an axis. In sketch 3, there is an axis and there is a triangle profile, right angle triangle profile, and one of the point, this point of the triangle is touching this chamfer circle now. Now I will go to the features, I will go to the extruded, not extruded, revolved cut. We have to cut the material around the axis. So use revolved cut. Now you can see here, so if I give this angle as 40 degree, okay, so this is how the material will be removed now. So if I try to increase the, okay, so this is how for the triangle shape, the material will be removed in this fashion. Means around the axis, the material will be removed like this. Can you see this now? Hope you can understand this concept now. Okay, so we created a triangle which is having 30 degree, right angle triangle which is having 30 degree angle. Okay, and within the triangle profile, we are cutting the material about an axis. Okay, is that clear? Like this. So this is how the material will be removed. Okay, uh, outside that circle and around the axis for the triangle shape. Okay, so then give this angle as 360 and then click it on OK. So now this will give us the chamfer. Okay, this will give us the chamfer onto the top face or the right face of the nut. Okay, so you can see, you can keep it in front view now. You can see the right face of the nut as chamfered now. So I'm going to hide this sketch number 2, which is so this sketch number 2 is which one, circle. So I'm going to hide it. Okay, it is not required, so therefore this is how it looks. Okay, so same thing, so same chamfer has to be given onto the left side. So in order to give this, I am not going to create one more triangle now. Okay, so what I do is I will just copy the chamfer from the right face to the which side, left side. How it can be done now? So whenever you want to copy the 3D features, under features tree, go to the mirror option. Okay, so then after selecting that mirror option, okay, now it is asking for mirror plane. Which should be the mirror plane? So my mirror plane should be the right plane now. So this is the plane about which we have to mirror the things, that is right plane. Okay, so select the right plane as the mirror plane. Then it is asking features to mirror. Features to mirror means this cut revolve. So this cut revolve should be used. Okay, the moment I select the cut revolve here, okay, cut revolve 1 as the features to mirror, you can see the preview in yellow color. So once it comes, click on OK. Okay, so now you can see, you can keep it in front view now. So both the sides have chamfer. You can make the hidden edges visible like this. So now this particular one is matching with this particular view, that is front view is matching with this front view here, and the side view, if you want to check the side view, go to the right side view now. Okay, so this is how it looks. So this is the right side view. So this is how it is looking. So both are same now. So this confirms the proper modeling of the nut now. So I am going to save this file, and before saving I am going to bring this model to solid form. Press Ctrl S, go for saving this file as part number 6. Okay, I'm going to name this as a load nut. Okay, because one more nut we have to model now, that is lock nut, that is the part number 7. So now you can see part number 7 is a lock nut. Again it is a M10 nut only. So again if you compare part number 6 with part number 7, both are geometrically similar except the with one thickness of the nut. In this case, in the part number 7, thickness is only 5 mm. So other than that, both are one and the same, because of which what I do now is I am going to copy this part number 6 as part number 7. That is, I will go to the file, I will go to the save as, and I am going to save this file as part number 7 again, and I am going to rename this as, instead of load nut, I am going to call this as lock nut now. So this is part number 7. Okay, so now, but in this part number 7, what has to be done? So in the part number 7, thickness should be only 5 mm instead of 8 mm. Now the question is where this thickness can be edited. So we had given the thickness of the nut when we used this boss extrude option. So I will right click on this boss extrude option. Okay, there I will go for editing the feature here. Okay, so then here we can change the thickness of that extrusion from 8 to 6. So because here the 8 to 5, so I am going to make it as 5 now. Then click on OK. So once you do it, okay, so if you have used the proper if you have followed the proper sequence of operations, definitely, okay, the model is going to be updated automatically with all chamfers and the cosmetic threads. Now you can see here, okay, so if you try to keep it in front view now, okay, the thickness of the nut is decreased. Okay, and you can also, if you try to go to the side view, okay, so it is looking like a hexagon nut only, and if you try to keep it in isometric view, okay, so it is again looking like which one, looking like part number 6 itself, but only difference now is thickness has reduced now. So just in one click we can change the thickness of the nut. So where it has to be done, let me show it again. So go to the boss extrude one. This is the first feature that we added. Okay. Okay, so there right click on it and then go to edit feature. That is first icon there. Then here you can go for adding required thickness. So if you don't want 5, suppose if I want to make it as 15, I can do. So your nut is going to look like this. Okay, but I want this to be now 5 mm. So I will right click on that. I will go to edit feature. Okay, so give this value as 5 mm now. Okay, is that clear? See, all these updation will occur only if all your created previous sketches are fully constrained. You need to remember that. That's why after creating every sketch, I was showing that in the status bar, the sketches are fully defined. Okay, are fully constrained. It is called as a constraint based modeling. Okay, constraint based modeling, CBM. Okay, constraint based modeling. Only if you are constraining all the sketches in every stage, then only the entire model will update automatically. Okay, otherwise you will not be able to see this kind of updation. Okay, so save this file, then close this one. So part number 7 is complete now. Okay, so that is lock nut is complete. Finally we have to make the shaft now. Part number 8, that is shaft. So creating shaft is very simple. It is a solid cylinder with a diameter of 25 mm here. Okay, but length is not given, but you need to remember that plumber block is used to uh, support the long shafts. So therefore, if this is the shaft, then where it will be placed, the shaft will be placed here. Okay, so the shaft will be placed here, or in the top view here, or in the top view of the body, the shaft will be placed along this axis. Okay, means along this axis here. Okay, so the shaft will come. So therefore, if you want to represent the shaft, if you want to show the shaft in the three-dimensional assembly, okay, so then your shaft should have length greater than 36 mm. So what I do is I'm going to take the shaft length here as 50 mm. Okay, so and where I'm going to create the shaft now? So I'm going to create the shaft in front plane. So I will select the front plane. I will go for sketch. Okay, and then I will select okay, so I will select circle command and let me draw one circle, and I'm going to give this diameter of this I think software is not responding. Okay, so now I'm going to give the diameter of this circle as 25 mm. 25 mm. Then once you add the dimension, you can go for adding the material within that circle by using extrude option, and add the material on either side of the sketch. And since length of the shaft is not given here, I am going to take it greater than 36 mm, or instead of saying greater than 26, we need to take it greater than actually. Let me show it here, because on this portion, okay, this bottom off and top off will come, and this bottom off and top offs are having width of 50 mm. So therefore, when we place this bottom off and top off here, okay, in the top view, okay, in addition to 36, the width of the bottom off and top off will be 50 mm already. So therefore, we need to take the length of the shaft greater than 50 mm. So I am going to take it as 75 mm. Okay, so I will take it as 75 mm like this. Okay, so this completes the modeling of the shaft. Okay, so I'm going to save this as part number 8, shaft, and save it. Is that clear? So this is going to be its front view, and this is going to be its right view. In the right view you can see the length, and in the front view you can see the circle. So keep it in isometric view and save it, and close the which one working window. Next we will see how these so now okay, up to now we have completed the modeling of body, cap, bearing bottom off, bearing top off, bolt, M10 bolt, M10 load nut, M10 lock nut, and the shaft. Means all the parts of the plumber block assembly have been uh, modeled. Okay, means they have been created. Now it's the time for assembling them. So next we will see how they can be assembled together.